Yeah, so in this video series, I'm going to teach you how to solve trigonometric equations, and they'll come in 3 sets. The first will be examples 1, 2, and 3, and then the third will be examples 7 and 8. Maybe I'll make a bonus 4th set with examples 9 and 10. All right, before we start, may the Lord Jesus Christ bless this video series. May He bless you and I. All right, let's get started. And the first example will be this, which is 4 cosine squared on the interval, and since our restriction is given in radians, our answer should also be in radians. It's clear that we should first add 3 to both sides of this equation, and we get, right? And then next we should divide both sides by 4, and that gives us, and after this, we should take the square root of both sides of this equation. And when we do, we get square root of 3 over 4 is square root of 3 over square root of 4, which is 2. This here is 2 equations. One is, and the other is. Now, a lot of students go from here without a calculator, because these numbers are nice, right? And use the unit circle, but do not use the unit circle because that's a lot of memorization. I'll show you how to get around them. When the cosine values or sine values involve root 3 and 2 and 1, then you should remember your 30, 60, 90 degree triangle. When they involve 1 and root 2, you should remember your 45, 45, 90. And when cosine and sine are equal to 1 or negative 1, you should just remember the sine and cosine graph. That way you get around the unit circle. All right, so what do we do here? Well, let's start with this one. Since cosine is a positive number and it's less than 1 on the right side, and needs to be, right? This number needs to be between negative 1 and 1, otherwise we don't have a solution. Now root 3 is about 1.73, so that divided by 2 is definitely less than 1. So since cosine is, most importantly, a positive number, what you should do is draw the quadrants really quickly, and then wherever cosine is positive, draw a reference triangle. That's in the 1st and 4th quadrants. So I draw a reference triangle here. And your reference triangle does not need to be drawn to scale. Just do it quickly, right? So that would be like something like this. And make a perpendicular with the x-axis, right? And now make the cosine root 3 over 2. That means adjacent side is root 3 and hypotenuse is 2. Got it. So that means that this angle here and the 30, 60, 90 that we have, since this will be 1, is 30. This reference angle, it's called a reference angle. But this reference angle right here is also 30. However, the actual answers will have to be measured from the positive x, right? Where we go counterclockwise if we have positive angles, and clockwise if we have negative angles. And I'll show you negative angles later, but yeah. The first answer will be counterclockwise, we go that much, and that's 30. So one of our answers is 30, but 30 in radians is pi over 6, so x equals pi over 6. And then the second one, again, we start with the positive x and go around, we encounter this. So even though the reference angle here in the 4th quadrant is 30, the actual angle is 30 shy of 360, so that's 330. But 330 is 11 times 30, so that's 11 pi over 6. So these are the 2 answers for that. And now for this, we draw reference triangles where cosine is negative. That's here and here. So reference triangles and reference angles. The triangle is a reference triangle, and the angle made with the x-axis is the reference angle. Again, we need cosine root 3 here and 2, root 3 over 2, so 2 here. But it's negative because it's in this quadrant and this quadrant. The reference angle is again 30 here and 30 here, but the actual angles are measured from, that's very tiny, but whatever, 30 here, but the actual angles are measured from the positive x again. So the first of them is this guy, and that's 30 shy of 180, which is 150, and the second of them is this guy, which is 30 more than 180, so that's 210. So 150 and 210 are the answers from here. So that's x equals 150 is 5 times 30, so 5 pi over 6. And then 210 is 7 times 30, so 7 pi over 6. So here are the 4 answers, the correct answers in this interval for that equation. And so we're done with example 1. Example 2 is this, which is 4 sine squared 2x minus 3 equals 0 on the interval negative 180 is less or equal to x is less or equal to 180. Okay, since we've done a similar equation with just cosine squared x, we could do the first part a bit quicker, which is you can all get to this. Well, first 3 over 4, and then from here sine 2x, important here, it's 2x not x, equals plus or minus root 3 over 2. Got it. Okay, and so where to from here? Well, we want to do sine inverse of both sides, but just as before, it's 2 equations here. One is sine 2x is root 3 over 2, and the other is sine 2x is negative root 3 over 2. So let's start with this one. So again, we draw the quadrants quickly and then put on some reference triangles where sine is positive. Sine is positive in the first and second quadrant. So, and we did that red, so stay consistent. There. There. Okay? And this time it's sine. So we need sine of whatever this angle is to be root 3 over 2, meaning opposite is root 3, hypotenuse is 2. Root 3, 2. Yeah? Okay, cool. So this reference angle this time is 60 right there. And this reference angle too is 60. Got it. But the actual answers are going to be measured from the positive x. So one of them is 60 itself. The other is 60 shy of 180, which is 120. But notice that means we have 2x is equal to 60, and 2x is equal to 120. From this first one, we see that x is 30. And from this second one, we see that x is equal to 60, right? Okay, cool. And then we could go around past 360 and back to this angle here, right? So this is what I mean. We can try and find more by going around here, but you see that that's going to be more than 360. But half of 360 is 180, so more than 360 will mean half of it is more than 180, so we don't need to look at that. All right, cool, cool, cool. So we just need to figure out where this equation has solutions now. And so I don't want this to get too crowded, so let's draw the coordinate axes again, but this time we're working with this equation, yeah? Okay, cool. For that equation, again, 4. My bad. Okay, that's better. Okay, this time looking at this, let me kind of highlight it. Okay, we want to know where sine of some angle is equal to a negative number. And this negative number is more than -1, so we're good. Yeah, okay, okay. Sine is negative in this quadrant and in this quadrant. So we throw a couple of reference triangles here and here, right? Okay? And we need to make sine root 3 over 2. So root 3 over 2 and negative root 3 over 2 because of where it's placed, right? Okay, cool, cool, cool. And so it means that now, because again, this reference angle is 60 and this reference angle is 60, we've got one answer measured from the positive x counterclockwise is going to be that, which is 60 more than 180. What's that? 240. So we get 2x is equal to 240 degrees, which means x is equal to 120 degrees, right? That's from this equation. But we also get this guy, right? and that's 60 shy of 360, so that's 300. So we have 2x is equal to 300, which means 2x is equal to 300, which means x is equal to 150, right? Okay, cool. We're done as far as the positive answers, but we could get negative answers. And by the way, like from this equation, there were some negative answers that I neglected, but I've been re-recording these videos a lot, so forgive me. And I'm also a little tired. All right, so I'll show you the negative answers because we're looking from negative 180 all the way to 180 on these two reference triangles, and then you could gather the two negative answers I missed from here, right? Okay, cool. But right now we're on this. On that, we've got the correct reference triangles, but because this time we are looking at negative angles, we go clockwise. So one of them is this angle, and that's negative 60. So we see that 2x can also equal negative 60. I just went clockwise, which means x is equal to negative 30. Okay, then we could also have this, which is negative 150, right? So 2x can equal negative 150. 2x equals negative 150, which means, whoa, that's not negative 150, my bad. That's negative 120. I should have known. See, I'm tired. I'm not lying. Negative 120, which means x is equal to negative 60. And these answers have symmetry to them. So clearly the other two answers are going to be x equals negative 120 and then negative 150. And these two are the two negative answers I missed from this equation. Yeah? Okay, cool. All right, this is it for example 2. And let's do our third example and wrap up this set. Our third example says this, which is 2 sine x is equal to sine 2x. And there's no restriction, so this time we're going to be able to see what you need to do when there's no restriction. Okay, so first I write 2 sine x is equal to, see, if you have a trig equation where the argument is not the same, the first thing you need to do is figure out how to make the argument the same. I've got an x here and I've got a 2x there. I need to fix that. And the way I fix that is by remembering what sine 2x equals with just x in it, and it's 2 sine x cosine x. In other words, this here is the correct substitution for sine 2x, and now I've got just a single x instead of 2x everywhere, so that's good. And then what I should do next is divide by 2 sine x, so I do that on both sides, of course. And the resulting equation will say on the left side we have 1 equals on the right side we have cos x. Okay, now as I said, when you don't have root 3, 2, and 1 and root 2 involved, it's not about the 30, 60, 90 or the 45, 45, 90. So when cosine and sine are equal to 1 or negative 1, you're dealing with quadrantal angles. So for those, what you should do is remember a graph of cosine and a graph of sine. And so if we draw the graph of cosine very quickly, here's what it looks like, right? This, well, 1, 2, 3, 4, 2 pi here, and then if we mimic this on the left, 1, 2, 3, 4, negative 2 pi here, right? And then 1, and then negative 1. Cosine is the one that starts at 0, 1, right? So it starts here and does this, right? It has a minimum here, and then again a maximum there. And cosine is even, so it's symmetric about the y-axis. So it looks like this on this part, right? Okay, so here we need to figure out where cosine is equal to 1. That's here, here, and here. But I only drew 2 cycles of cosine. Cosine goes indefinitely to the right and left, right? It goes on forever. And since I don't have restriction, I need to catch all the places where it's equal to 1, not just these 3. Well, I could gather from there where all the other places are going to be. So the answer to this is going to be x is equal to 0 plus integer multiples of 2 pi. So 2 pi n for n an integer. And this is correct, I know, because I started from 0 and then I went 2 pi, and I see that if I went another 2 pi, I'd get to another peak, right? And I said n is an integer, so this will catch all the ones on the left side also. But it's kind of silly to write 0 here, so let's not. 0 plus y. So we could just write this is our answer. And notice when n is equal to 0, I have x is equal to 0. That's this one. When n is equal to 1, I have 2 pi. That's that one. When n is equal to -1, I have -2 pi. So by plugging in different n values where n is an integer, you catch all of them. Yeah? All right, cool. I hope you enjoyed this, and I'm exhausted, so take care.